Hi, everybody. Today we are going to be talking about Unit 2.1.4, which is simplifying fractions. We are also going to trickle right into the next topic, which is comparing fractions. Simplifying fractions, we're working really on how do we create equivalent fractions. And one way to create equivalent fractions is if we have a fraction that we can reduce. We can create an equivalent fraction that way. And then in the few pages past simplifying fractions, we look at a method to figure out our least common multiple, which is your upside down division symbol method. And we'll check out another kind of tried and true method to do that too. And then those methods are used to help us really compare our fractions by getting common denominators. So that's what we're going to be working on in this next portion of the video. This topic in particular, just this page right here, is talking about simplifying fractions. And so here we're going to start with this definition of what are equivalent fractions. And equivalent fractions are fractions that represent the same part of the whole. So the same part of the whole. So your examples, I'm going to move down so I have a little bit more space. But let's say we're coming up with equivalent fractions of 1/2. So pick anything you want, like that would end up reducing to 1/2. So maybe we've got like 14/28, or we've got 3/6, or we've got -2/-4, or we've got something like 50/100. So those are all going to end up being equivalent to one another because they all reduce down to +1/2. And some of you might be like, whoa, wait a second. What happened with that -2/-4? Well, the negative over negative gives you a positive, and then the 2/4 gives you 1/2. And so kind of the directions of, well, how do we do that to find, like, how do we find those equivalent fractions? So now I know what an equivalent fraction is. How do I find that? Well, we are going to either multiply or divide. Multiply or divide the numerator and the denominator by the same number. So for example, let's kind of take my problem that I had of, okay, well, I had 1/2, and how in the world did I create 14/28? Well, if we are multiplying both by the same number, that would be us going, okay, well, let me multiply by 14 here. But if I multiply by 14 in the numerator, you also have to multiply it by 14 in the denominator. And that gets you to 28. That works the other way around though, too. So let's say we had the 14/28 and we're like, well, how can I reduce that? Well, I see that they are both divisible by 14. So if I divide them both by 14, the numerator and the denominator, and again, think about, well, why do we do that? What is 14/14? 14/14 is 1, right? So that's why we're creating equivalent fractions, because if I divide something by 1, or if I multiply something by 1, that's 14/14, that's that multiplicative identity property, right? So if you multiply something by 1, you maintain something's identity. We are just creating an equivalent fraction. And so coming back to this example here, if we divide both things by 14, 14/14, which is 1, 14 divided by 14 gives me 1, 28 divided by 14 gives me 2. And so that's, again, just showing you, I know this is like an oversimplified example, but it's showing you how to create those equivalent fractions. Excuse me. So when we're looking at this next example, it says, write an equivalent fraction to 2/3 that has a denominator of 27. Again, ask yourself. And so it kind of comes down here to this think question. So think, 3 times what number is going to give me 27? So 3 times what number times what number equals 27? And I'm hoping, so again, you're kind of like, 3 times what is going to give me 27? On the flip side of that, you could also say 27 divided by what is going to give me 3? Like, that could be the other question that you're asking yourself. Again, I know this is an oversimplified example, and I would hope you would say 9. Well, 3 times 9, or 27 divided by 9, 3 times 9 will give you 27. 27 divided by 9 will give you 3. So that means that up here, in order to figure out x, we would also multiply by 9, and 2 times 9 is going to give you your x, and your x is going to equal 18 for that. And so you would end up for your answer getting 18 over 27, and you would say, okay, does that actually get me back to what I started with if I reduced it? If I reduced it and said, well, let me divide those by 9, and what do I get? 2/3. Bingo, I got what I started with. So yes, that was the correct answer. So let me fill in this other blank. The answer, which is 9, so we are going to multiply the numerator and denominator by 9. All right, so let's check out the next one. John is making cookies for a bake sale. He made 52 large cookies, but he wants to give away only 3/4 of them for the bake sale. Every time I read this problem, I'm always like, only 3/4 of your cookies that you just made? That's a lot of cookies that you're giving away. I'm like, only 3/4 of them? Oh my goodness. Like, I want to eat the cookies. I don't want to give 3/4 of them away. Anyway, so it says, what fraction does he give away using 52 as the denominator? And so you're saying, I mean, another way to think about this is like, what is 3/4 of 52? Like if you're giving away 3/4, like what is 3/4 of 52? Or you can set it up like fractions, right? You can say 4 times what? I'm going to fill that in here. So 4 times what number is going to equal 52. And so you can put it in your calculator if you want to. You can do some trial and error. So you could say, what is 52 divided by 4? And that should give us 13. So then that means 4 times 13 is going to give me 52. Well, that means 3 times 13 is going to give me 39. So the answer of 13, so that means we are going to multiply the numerator and the denominator by 13. And then that would mean that John, oops, not 13 there. I want to write it down over here. John is going to be giving away 39 of his delicious cookies. So 39 cookies. One other way you could solve this is, well, I'm thinking of a couple more ways you could do this. But one way that I've had students ask, well, you know, I see I have a fraction here and a fraction here and it's separated by an equal sign. Can't I just cross multiply? You sure can. You sure can. So if you have something like that, you're more than welcome to cross multiply, and you would get 4x equals 52 times 3. Then you would do 52 times 3, and then you would divide it all by 4. And that would end up giving you 39 as well. The other thing I talked with you about briefly was, I mean, essentially we're asking the question, what is 3/4 of 52? And that 3/4 of 52, if you are converting this sentence here into like a mathematical equation, what would be our x is our equal sign. 3/4 of is multiplication, 52. And so you're doing the same thing. So you're multiplying 52 times 3 and you divide it by 4. Well, that should look exactly like what we just did with this process as well. So there's lots of ways you guys can go about doing these problems. So here we go, filling in our blanks. A fraction is in simplest or lowest terms, or it has been reduced. Those are all equivalent phrases or synonymous types of words. When the numerator and denominator have no common factor other than the number 1. So that's how we know that it's been reduced, is that there's no other common factor other than 1. So one example, let's say if we have like 18 over 27. So that one, I mean, we talked about that one up top too, but we would say, okay, what can we take out of that? Some of you might just say 3. And so let's say we did start with 3. And so then we would get 6/9. And then I would hope you would look at that and say, oh, I can keep going. There's another 3 I can take out. It's absolutely true. So then you would end up getting 2/3. You can also just start from the very beginning. You can say, well, I see that I can take out a 9. Well, that makes sense, right? If I take out a 3 and a 3, 3 times 3 is 9. So 18 divided by 9 is going to give you 2. 27 divided by 9 is going to give you 3. The next example I want to look at is 54/72. And think about like what you might want to take out. So I encourage you to kind of pause the video for a second and see what you think you could take out and see if you get to the right answer. For me, I think about taking out a 9 first. And so then 54 divided by 9 is going to give me 6. 72 divided by 9 gives me 8. And I say, okay, well, I could have taken out a larger number, it looks like. So let me try taking out a 2 now. And then that's going to give me 3/4, and I'm done, because the only common factor between 3 and 4 now is 1. And so I know that I'm done with that problem. What that also means, by the way, is that here, 9 and 2, 18. 18 was the greatest common factor that we could have taken out. So I could have started that one by taking out an 18 to begin with. Okay. Number 3, let's try this one. 13/56. 13/56. So pause the video. I want you to think about if you can do this one on your own. What I look at is, or what I'm thinking about is that the factor, or that the number of 13 is a prime number. And so then I would be thinking about, okay, is 56, can I divide 56 by 13? Is it going to go in there equivalently? And the answer to that is no. It's not going to go, or equally. I didn't mean equivalently. Is it going to go into 56 equally? No, it's not. We're going to have a remainder. So what that means is that this is our final answer. So that it's already reduced as much as it can go. There's nothing else I can take out. So that would be your final answer. And then my last one, we're going to have -32/48. -32/48. Again, I encourage you to kind of pause the video and see what you can take out here. We could just jump to 16 if we wanted to. I don't know if you would jump to 16. So maybe like, let's try 8. So if we're going to divide 32 by 8, we would get -4. And 6 times 8 is 48. So that would be a 6. Then we can divide them both by a 2. So it could be -2/3 for our final answer. All right, so let's look at the next page. So this page is kind of prepping you for what's coming, the next topic of comparing fractions. So this part, the least common multiple. Let's fill in some words here. Because this chunk up here is kind of describing to you what a least common multiple is, and prime numbers and relatively prime. It's talking about those different terms in here. So it says the least common multiple of a set of numbers is the smallest number that is a multiple of all the numbers in the set. So like, for example, if we did, what's the least common multiple of 2, 3, and 4? That's what it's asking you. And so it's like, what's the smallest multiple? That would be the common number, or the common multiple of all 3 of these. But what's the smallest one of those? And so typically how I've been taught, what I was taught like back in grade school, was to take the largest one and to just do multiples of it. So we would do like 4, 8, 12, 16, 20, 24, 28. And we'd keep going if we needed to. And then I'd stop. And then I'd say, okay, are 2 and 3 going to go into this? No. Will 2 and 3 go into 8? No. Will 2 and 3 go into 12? Yes. So 2 and 3 will both go into 12, and obviously 4 does too, because this is my row of multiples of 4. So that would mean that my LCM would be 12. Well, we are getting ready to show you a different method than this one, because sometimes this gets a little, I don't know, it gets a little bit hard and it becomes a long process, especially if your numbers are much larger that you're starting with. So we're going to give you like a tried and true method down here that this absolutely finds the least common multiple without it taking forever to do so. All right, so here we go. We're going to keep talking about what it means to find a least common multiple. So for example, the least common multiple of 6 and 9 is 18, because there is no smaller number that both 6 and 9 go into evenly. The least common multiple of 5, 6, and 9, again, you should try it out and see what you find when you do 5, 6, and 9. And what you would end up finding is that the LCM for these is going to be 90. And again, typically we would start with this 9 and we would just start doing multiples of it, like 9, 18, 27, 36, and we would keep going until we got all the way up to 90. And that would take a while to figure it out, to be like, wait, it's 5 and, is 5 going to go into this, 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 this? Nope. And so it just takes a little bit to find it. So that's, again, the method we're going to show you is a better method to come up and find these. If numbers in a set share no common factors other than 1, the numbers are considered relatively prime to each other. So here's your definition. Relatively prime to each other. So that means like the numbers 5 and 8 as a set of those numbers are relatively prime. And I know you might be thinking, well, wait a second, 8 is composite, it's not prime. Well, they're relatively prime to one another. Let me fill it in. Even though 8 is composite, they are relatively prime compared to one another because they don't have any other common factors. And the largest number that is going to be divided by both of them is 1. And so that's why they're considered relatively prime. All right, so this is because 1 is the largest number to divide into both numbers, which is what we were just talking about. The numbers 2 and 8 as a set are not relatively prime because 2 divides evenly into both numbers. Numbers can only be relatively prime with relation to each other. And if 2 numbers are relatively prime, their lowest or their least common multiple is their product. So for example, these two, 5 and 8, because 5 and 8 were relatively prime to one another, because the only of their factors, the only one that is common that will go into both of them is 1. And so when they're relatively prime here, their least common multiple is going to be their product. So 5 times 8 is going to give you 40. And so that would be their LCM for that. All right, so don't get caught up too much on that terminology here. It's just a matter of just making sure you knew the terminology when we get ready to reference it down here. Okay, so to find the least common multiple, or the LCM, if you'd rather just abbreviate it, least common multiple of 2 numbers, we can follow the following steps. So draw an upside down long division sign with the numbers inside separated by a comma. And then we are going to take the largest number that you notice that divides into both of these numbers that are inside the division symbol, and we're going to write it to the left of the division symbol. If the largest number is 1, the numbers are relatively prime. So the LCM is going to be their product, and you're finished. If not, continue the process. So divide and drop the quotients down to below those numbers that we started with inside that long division symbol. And we're going to repeat steps 2 and 3 until the largest number to go into both numbers is 1. And then the LCM is going to be the product of all of the numbers along the left and the 2 numbers at the bottom. These steps make a whole bunch more sense after we start working on a few examples. So you have got space, a little bit of space here, and then we gave you another page over here to do some examples. I'm going to show you an example right here, so that way we can kind of reference our steps on the same page. If you don't have space, just go to the next page where you've got more, and then you can kind of look at the steps that are on the screen right here as you're doing your examples. All right, so one example I want you to start with is 36 and 90. 36 and 90. So step number 1, it says draw an upside down long division sign with the numbers inside. So we're going to do an upside down long division symbol with the numbers inside separated by a comma. And then you're looking to see, well, what can go into them. And it doesn't even have to be the largest one, right? Like it can be whichever one you want. Like you might actually see that, okay, they appear to be both divisible by 3. They appear to both be divisible by 2. Well, guess what? That means they're both divisible by 6. If you don't see any of that, if you're just like, I see that they're both end in an even number, so they have to be divisible by 2. Let's just try that and see what happens. So then we keep going and we say, well, 36 divided by 2, that's going to give me 18. And then 90 divided by 2 gives me 45. And then I drop that down and it says, we're at this stage now, divide and drop the quotients below the numbers we started with. We repeat steps 2 and 3 until these 2 numbers, the only common factor in both of them is 1. So I look at 18 and 45 and say, can I take anything else out? Yes. I see that we could take out a 9. So we could take out a 9. And then if we drop that down, 18 divided by 9 is going to give me 2. 45 divided by 9 is going to give me 5. And now I look at these 2 numbers and I say, is there anything else I can take out of them? Is there any other common factor? And the answer to that is no. So what that means is that my LCM is the product of all of the numbers along the left. So that's like right here, and the 2 numbers at the bottom. And look at what shape that makes. It makes an L. Maybe it'll help you remember. It's for L for LCM. So we're going to take the product of those numbers. So 2 times 9 times 2 times 5. And we're going to multiply it together. So I see that 2 times 9 gives me 18 and 2 times 5 gives me 10. And then 10 times 18 is going to give me 180. So what that means is that my LCM, my least common multiple between 36 and 90 is 180. All right, so now let's try some more examples. We've at least got one underneath our belt. So here's example number 2 of 24 and 48. So let's do our upside down division symbol. Separated by commas. You might say, well, looks like 24 would go into both of them. You could just jump to that if you want to. And then we would say, okay, that is going to be 24. And so then I'm going to get 1 and 2. And guess what? Between 1 and 2, we're done. There's no other common factor. And so I take those and I multiply them. And so I'm going to get 24 times 1 times 2. You don't really have to put the 1 in there. And then 24 times 2 is 48. So 48 is your LCM. And then let's try 15 and 8. We're going to try 15 and 8. So then put them in your upside down division. And let's look between 15 and 8. So 15, thinking about factors, we've got like 1 and 15, 3 and 5. None of those go into 8. So this is exactly when you're like, oh wait, these are relatively prime to one another. So the only thing that's going to come into them, go into both of them is 1, and then we would drop them down, right? 15 and 8. And then think back to what we talked about over here. If two numbers are relatively prime, which is what 15 and 8 are, the LCM is going to be the product of those numbers. So these are relatively prime. To one another. So we just take their product. So we would end up doing 15 times 8. That's going to end up giving us 120 for that. So that's our LCM. All right. So then I'm going to give you 2 to try on your own. What number are we on? We're on number 4. So I would like for you to try 64 and 96. I'm going to tell you what the answer is just so you can check. The answer, LCM, is going to be 192. So you can end up getting 192 for your answer. So I want you to do that one. And then the other one is going to be, where is it? 24 and 60. 24 and 60. So I want you to do that one too. And the answer for that one, once you get there, should be 120 for that one. But go ahead and pause the video right now. Do those 2 problems. See how you do. If you don't end up getting them correct, then let me know. You can ask me in office hours. You can send me a text, send me an email, ask me in class. Just make sure you reach out and ask for help. All right, so finding our least common multiple continued. So to find and we're going to find the LCM of 3 or more numbers, we're going to follow the steps below. So we're going to draw an upside down division sign, just like what we did before, with the numbers inside separated by a comma. We're going to take the largest number that you notice that would divide into all the numbers inside, and we're going to write it to the left of the division sign. If the largest number is 1, skip down to step 5. Divide, and we are going to drop the quotients down below the numbers. And then we're going to repeat steps 2 and 3 until the largest number to go into all of the numbers is 1. Then we're going to take a number that you notice divides at least 2 of the numbers and write it to the left of the division sign. If the largest number is 1, now you skip to step 8. And number 6, divide any numbers that you can by that number and put the quotients below. Then drop the remaining numbers down unchanged. So this is the part that's a little bit different. Drop the remaining numbers down unchanged. Repeat steps 5 and 6 until the largest number that goes into at least 2 of the numbers is 1. The LCM, same as before, is the product of all numbers along the left and all numbers at the bottom. Okay. So I know it's a bunch of words. It'll make more sense once we get to do some examples. All right, so we're going to look at 4, 6, and 8. And again, some of you might be like, I can do this. I'm just going to do 8, 16, 24. It's going to be 24. The answer is 24. Okay, great. But let's show you. I'm going to show you the upside down division piece because it's best to start with an easy example, and then we work with a harder example. So what we know is that the LCM, it should come out to 24 as long as we do our process right. So let's say if we are going to do our process right. So looking at the steps, here. It says draw an upside down division sign, put the numbers inside separated by a comma, take the largest number that will divide into all of the numbers inside. All right, so I see that we could take out 4 out of these two, but not out of all 3. And so I'm going to take out a 2 because that's the number that I see that I can take out of all of them. So then I'm going to drop down. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Are there any other common factors between all 3 numbers? The answer to that is no. So now you look between sets of numbers. Is there anything between 2 and 3 we could take out? No. Is there anything between 3 and 4 we could take out? No. Is there anything between 2 and 4 we could take out? Yes, we could take out a 2. So let's take out a 2. And so we're kind of looking, we've looked at these steps now. So, we're looking at what can we take out of the 2 numbers inside. Well, now we're going to divide it. We're now at step 6. We're going to divide it, but then we're going to drop the remaining numbers down unchanged, meaning this right here. 2 divided by 2 is 1. 3, there was no common factor, right? So that's the one that's going to drop down unchanged. And then 4 divided by 2 is 2. Now we look between all 3 of these and we say, is there anything else I could take out of any pair of them? The answer to that is no. So now you look at that L shape and you say, let's multiply it together to get my LCM. And I'm going to get 2 times 2 times 3 times 2. So that's 4 times 6, which gives me 24, which is exactly what I was expecting. So that's great. We did that process correctly. So now let's try something that's a little bit harder. So we are going to be looking at the numbers 12, 18, and 24. So we're going to put those in the upside down division symbol, 12, 18, 24. And you say, okay, well, what could I take out of all of them? I'm seeing a few different factors we could take out. I'm just going to take out a 3. You might have seen something different. You could have seen a 2, you could have seen a 6. You could try something else, but I'm going to do a 3. So here, 12 divided by 3 is going to give me 4. 18 divided by 3 is going to give me 6. 24 divided by 3 is going to give me 8. The next number I see that will come out of all 3 of them is a 2. So I'm going to take out a 2. So I'm going to get 2, 3, and 4. And look, I'm right back to where I was right here. So then that means I can take out a 2, and then I'm going to drop down a 2. I bring down, I'm sorry, that should be a 1. So 2 divided by 2 is going to give me 1. I'm going to drop down the 3. 4 divided by 2 gives me 2. So then you're finally taking these along the outside and you're multiplying them together. And so we get 3 times 2, which is 6. 6 times 2 is 12. Times over here another 6, and we should be getting what, our 12 times 6, that's a 2, 12, 72. All right, and that's your LCM for that. Let's do, I'm going to do one more and then I'm going to give you 2 to try. 2 to try. All right. The one we are going to do one more together is going to be 15, 20, and 25. And here, it looks like we could take out a 5. So we're going to get 3, 4, and 5. And kind of looking between all of those numbers, it doesn't look like there's anything more we can take out here. Because there's nothing between 3 and 4, there's nothing between 4 and 5, nothing between 3 and 5. So multiplying them all together. So I'm looking at the fact that 5 times 4 is 20. And 5 times 3 is going to give me 15. 15 times 2 is 30. And then I've got that extra 0. So the LCM should be 300 for that. All right. I'm going to give you 2 to try on your own. So number 4, you are going to do 4 8 and 15. 4, 8, and 15. The answer to that when you're done should be 120. And then the last one, don't be afraid of a giant number because it is a big number. You're going to try 54, 78, and 96. 54, 78, and 96. If you're not sure what goes into them, just start with 2 because the 2 would definitely go into all of them. And the answer you should be getting from this one is 11,232. So big number there. Okay, so that preps us, all of that work, for comparing fractions. So comparing fractions, I'm just going to do a few more examples and then I'm going to turn this over to you guys. Then we're going to do the rest of this as like a group activity or a discussion activity. So unit 2.1.5, comparing fractions, we are going to first rewrite one or both fractions so that they have a common denominator. And then we are going to compare the numerators of those fractions. So for example, I mean, this is again, oversimplified example, but let's say we were comparing, I don't know, something like this. So if we were comparing them and you're like, oh, I'm not sure which one's bigger. Well, 2/3 is going to be bigger, right? So we can, I'm going to show you a couple different ways we can do this. But if we are just following our directions here, where we're rewriting one or both so that they have a common denominator, excuse me, we're going to take the 2 and the 3, and you can do your upside down division method if you'd like, or you can say, hey, wait, those 2 numbers are relatively prime, and that means that our least common multiple is going to be 6. And so that means that my least common, like my denominator there, can be 6. And so I would say, okay, 2 times 3 is going to give me 6. And 3 times 2 is going to give me 6. And so now that we have common denominators, now we look at our numerators and we say, oh, 4 is greater than 3. So 2/3 ultimately would be larger than 1/2. And so that's what it's asking you to do here. Again, I've had students ask me, how do I know which one's less than, greater than? I just look at it from left to right. So like if I'm reading this from left to right, I'd say 3/6 is less than 4/6 because this is the smaller side of it, right? It's less than 4/6. Or if you want to read it from the 4/6, 4/6 is greater than 3/6 because you're reading it this way, and you hit the greater side of that inequality sign. The other thing I've heard people do is say, oh, it's like an alligator, and the alligator, that's supposed to be alligator teeth, is eating the larger fraction, the larger value. All right, so coming back to number 2, we're comparing the numerators. One might be less than, which is less than, or it could be greater than, and I'm filling in the word greater than. Or it could be equal to the other one. And so we are going to do these first 3, and then I'm going to have you guys finish the rest. So on this one, you've got a choice here. You can either say, well, let me get common denominators. And so common denominator I see between 4 and 12 would be 12. So I've multiplied this by 3 and this by 3, and then I'm getting 1/12, and then I'm getting 9/12. Well, 9 is definitely larger than 1. So I would go like that. And so 9/12 is larger than 1/12. So that means 1/12 is less than 3/4. The other thing you can do, I've had students say, Liz, I can look at this and say that 1/12, if I split this pie into 1/12, and we keep going, the 1/12 is going to be like a little sliver in here, right? Versus 3/4 is going to be this much of it. If you want to draw something like that, and you can say, well, this is 3/4 and this is supposed to be 1/12, and this one's larger, that's fine. I don't care if you do that. But you either have to draw a picture or you have to write in words. And so for me, it's just easier for me to just kind of show it out in numbers, but that's up to you for what would be easiest. All right, before you get ready to get a common denominator here, I would look at them and say, is there maybe an easier way to do that? And I'm hoping you would say, oh wait, 2/4 is 1/2, 3/6 is 1/2. Therefore, these guys are equal. So this is just going to be that they're equal. Here, this is another one we get to kind of use our brains for. You can say, well, this is 3/5 and this is 1 2/3. So something that has a whole number in it, that's a mixed number versus a proper fraction over here, that's always going to be greater than that proper fraction. However, if you would prefer to just kind of say, you know, I just want to stick with the same way, I've had students say, okay, I'm going to get a common denominator of 15. And so instead, they would do 9/15, and then they would do times 5 times 5, and then it would be 25/15. And they would say, well, 25 is larger than 9, and that works too. So there's so many different ways to do this. The point is that you have to choose a way, and then you have to show your work. And so what I want you to do, I want you to finish the rest of this page. 4, 5, and 6, you're doing similar things that we were just doing for 1, 2, and 3. For the next part, 7, 8, 9, and 10, it says state which of the following are equivalent. So some of them, are going to be equivalent and some of them aren't. And so you're just showing me, you know, how you're determining that. So how are you determining that they're equivalent or not equivalent? So you need to show your work and do some steps here showing me how you determined they were equivalent or not. And then for this last portion down here, it says state which of the following are true statements. So again, show your work for showing me how you have determined that these are true statements or that they're false statements. And then that's it. That's it for this topic. So thanks for tuning in.